on the bayous of southern Louisiana is much the same now as it has been for decades. Dredging for oysters is a livelihood for many, and the waters in marsh country abound with shellfish, wildlife, and game. But the traditional is giving way to change, to progress. This is progress, the beginning of a pipeline to carry the natural gas energy needs of a growing America. Surveying a trench 129 miles long was a monumental task. Surveyors first had to lay out the line, using new radar instruments for the long stretches. When they came to a road or one of the 91 pipeline crossings encountered, they used conventional equipment. Care and accuracy were required to cross the 71 navigable waterways and canals, and to be on the mark across the 9 large bays. Putting in a pipeline is like assembling an army, then getting it on the move, into action. While the survey crews were wrapping up, flotation ditch was being dredged, and from distant places in Pennsylvania, California, and Texas, pipe was in transit to the coating yards near New Orleans. By rail and water, the lengths of pipe were delivered and inspected by our people. A protective coating called Semastic was first applied, then inspected for flaws and proper thickness. Quality was controlled every step of the way by Columbia's own personnel. Following the application of Semastic, a tar-like substance which protects the pipe from the elements, each length of pipe, called a joint, was given a lime wash and in minutes dried in the hot Louisiana sun. To protect the ends of each joint, a cover is put on before the Semastic application and lime bath, then removed before the drying process. The coating yard is a bustle of activity, as pipe is constantly being transferred from the lime wash section to the concrete coating area, and new pipe is brought from the storage lots into the sheds for priming and Semastic application. For the concrete coating operation, each joint is transferred from the truck to the skids near the coating area. When the joint receives its final concrete and wire mesh cover, the whole thing will weigh in excess of 25,000 pounds. Why all the weight? Well, when that submerged piece of pipe is finally filled with gas, the concrete will provide enough weight to keep it securely on the bottom. The concrete is sprayed on the rotating joint, and wire mesh is fed in so that the concrete will be held firmly in place. The whole procedure takes only minutes, and when it's all finished, the joint is removed and stored for a drying or curing period of at least 72 hours. With heavy weights like these, the loading and transportation process is lengthy. From truck to barge, this is the last time the joint is moved until it's ready for welding at the job site. Here again, Columbia people inspected each joint to be sure no damage has occurred during handling. A single tug swings the string of barges out into mainstream of the intercoastal waterway. From the coating yard, the trip by water through the back reaches of the marsh country can take several days, and maneuvering the narrow canal tests the skill of the best captain. Destination finally reached, the pipe is ready for use. The process of digging a ditch for the line is actually accomplished in 2 steps. This is real Louisiana gumbo. In the flotation ditch, the highway upon which the lay barge and other craft must move is dug out, yards and tons at a time, with huge drag lines. The new canal, about 50 feet wide and 8 feet deep, accommodates all the equipment easily, and a huge drag line is moved in to dig still further down for the pipe trench. The skill of the operator is amazing. He accurately judges not only where he has to dig, but at what depth the drag line has to work in order to get the pipe at the proper level in the trench. All pipe is lowered to a depth of 10 feet from water surface at mean low tide to the top of the pipe. This is a hard, hot, and seemingly endless task. When the snow flies in West Virginia, Pennsylvania, or Ohio, it probably will occur to only a few that during the heat of summer, men and machines work 12-hour shifts, sometimes even around the clock, slogging through nearly 130 miles of swampy gumbo to put in a pipeline, a line that puts natural gas energy in the factories and at the fingertips of the householder. Doesn't that look a little like an old-time railroad train? Or perhaps a prairie schooner? But no, it's the lay barge, where the joints are actually welded together. The lay barge is a floating fabrication plant, and the barge, together with its equipment, is completely self-contained. Construction here differs greatly from dry land work, basically because there is rarely any solid footing. As a result, the entire operation literally floats. Looking down from the wheelhouse of the tug, you can see how the pipe is stored and held at the ready, how it's transferred and prepared for welding. Since the complete operation is all in a line, every worker is an integral link in the construction chain, right down to polishing the bevels and the joint ends. Pipe is stored ahead of the welding positions, and as each joint is called for, it's transferred back to the first station. Then, as a new joint is added, the tug moves the whole lay barge operation forward and out from under the pipe. Each joint is thus advanced to another workstation, and one more completed joint goes off the rear into the ditch. The whole operation resembles an assembly line. Without welding, there would be no pipeline, for the welders are the men who tie it all together. Each of the 4 welding stations performs a function. The first sets the internal lineup plant and applies the stringer bead, a critical job calling for the best of welders. Number 2 applies the hot pass, the 3rd fills, and the 4th caps the weld. And talk about hot jobs. He's checking the stringer bead and backup welding when necessary. Oh yes, he does get back out. The completed welds are cleaned, ground, and doped. Once again, Columbia people inspect all the welds before application of the final somastic coating. To make each of the welded joints impervious to water, a coating of somastic is applied under extreme pressure by a huge jaw-like machine. This field coating now leaves no bare pipe exposed, and it's ready for years of uninterrupted service. A final inspection by an electronic device called a Jeep detects any possible holidays or holes in the coating. Then a signal is given, and the barge moves forward to receive a new joint at the front end, as the completed section of pipe slides gently home into the water. To make sure the pipe is in a proper position and depth, an inspector and the spread foreman make a final check. But work along the pipeline wasn't all gumbo digging, for problems existed every foot of the way. Roads had to be crossed, not by digging them up, but by boring under them. Traffic on navigable canals couldn't be disturbed, but the line had to push through.
Sure to have the Houston contractor block.
Let's have an aerial look at a river crossing. Come on, step aboard. And in moments, we'll be out over the Chapelire River. That's a suction dredge spread out across the river. Like a giant vacuum cleaner, it sucks mud from the river bottom and pumps it to a spot on the bank where it will be away from the pipe ditch and won't become a hazard to ship traffic. Oh yes, there were a few spots where the land would support equipment. For instance, here at the Wax Lake outlet, terrain was firm enough to hold most of the heavy gear, but it was tough going. Bulldozers needed heavy planks under their treads, and side booms had to have additional support. The men were wet and muddy most of the day. There were snakes and mosquitoes, big ones, but work went on. Bends were made in the pipe, and often the pipe and machines together looked like great monsters. Where the land met water, laying the line became a situation of teamwork. Men and machines, on barges and ashore, worked together to push the line across. While pipe was going in here, compressors, new, modern ones, had to be installed up the line, perhaps hundreds of miles away. This is the latest natural gas-fired, jet-driven compressor, one of several that together provide an additional 91,500 horsepower to move the increased supplies of energy. Needs of modern man have forced him to intrude in the Gumbo country, to tap Louisiana's reserves of natural gas, which have no value unless sent to market. Though the sounds of men and machines are gone, the vast swamps quiet, that reserve is being tapped. Beneath the Louisiana Gumbo, gas is moving to market through another vital link in one of America's longest energy arteries.